All right, let's look at study guide number 2. Again, this one that I have in front of me right now is the printout from what you have in Canvas. We are going to switch over to the paper copy for a few questions, just because it didn't print out very well on the Canvas version. All right, let's look at the very top question. It says, use the following information to answer questions 1 through 3. There are 64 pretzels in a 16-ounce bag of chocolate-covered pretzels. Number 1 says, what is the number of chocolate-covered pretzels per ounce? So we want to find pretzels per ounce. So if we go back up to our problem, there are 64 pretzels. Per means to divide. Ounce would be 16. So if we simplify that down, we can divide both of these by 16 actually, and we get 4 over 1. So there are 4 pretzels for every ounce. Question number 2, how many ounces does each pretzel weigh? So we're thinking ounces per pretzel. So we need to take our ratio that we wrote up in question 1 and flip this. We're going to put the ounces on top and the pretzels on bottom. So 16 ounces per 64 pretzels. Again, simplify and divide both of those by 16, and we get 1/4. So 1/4. Or we could put that in as 0.25. Question number 3, find the number of chocolate-covered pretzels in a 5-ounce bag. So if we go back up to question 1, we found that there were 4 pretzels for every ounce. So if I have 5 of these, I need to take my 4 pretzels per ounce times the 5 ounces. So 4 times 5 gives me 20 pretzels. All right, let's look at our next section. Use the following information to answer questions 4 through 7. The local farm market sells peppers at 5 for $2.25. Question 4 wants you to complete the table, which did not print off well, so we're going to switch and use the paper copy. All right, so we've already filled in that 5 pretzels is $2.25. So we need to start with finding our unit rate, or how much it costs for 1 pepper. So we're finding the cost per pepper. So I'm going to write over to the side, cost per or divide pepper. So from the table, we know that it would be 225 divided by 5. And when we do that, we get that each pretzel costs 45 cents. So to fill out the rest of your table, you would need to take your 45 cents times the number of peppers you are purchasing, and that will give you what your cost is. All right, let's look at question 5. How many peppers could you buy for $20? All right, so we know we have $20 and each pepper costs 45 cents. So we're going to take our total amount that we have and we're going to divide it by our 45 cents. When we do that, I believe we get a decimal. Let's see, 20 divided by 45 cents gives us 44.4 repeated. Now if we go to the store, we're not actually going to be able to buy this 0.4 of a pepper. They won't sell that to us, so we would only be able to purchase 44. Question 6, write an equation that relates the number of peppers in and the cost C. Well, we know from our table that 1 pepper costs 45 cents, so that is our constant. That's what we multiplied each of those amounts by. Our general form of our equation is y equals k times x. They've given us different letters here, N and C. You can use N and C, or you can continue to use y and x. So our equation would be y equals 0.45 times x. Question 7, what is the constant of proportionality? We can find that easily from question 6 or from your table. That 1 pepper was 45 cents, so 0.45. All right, our next section. Use the following information to answer questions 8 through 11. The engine in Paul's Weed Whacker uses an oil-gas mixture. The owner's manual recommends mixing the oil and gasoline together. It states 1/8 ounce oil with 4 ounces gasoline. Paul buys a 32-ounce bottle of oil, but only wants to use 1/8 of it and to save the rest for future use. Question 8, what is the unit rate of oil to gasoline? We're going to report our answer as a decimal. Says do not round, the computer will round it for you. All right, if we go back up here, we notice that it states 1/8 ounce oil with 4 ounces of gasoline. So we are doing oil to gas, so 1/8 divided by 4. And to work this, we are going to keep change flip, so I'm going to make that into a fraction. So times 1/4. Times 1/4. When I do that, I get 1/32. So 1/32, which when we divide that out, we get 0.03125. On Canvas, if you enter this in, it will automatically round this up for you due to the number of decimal places. Question 9 says to fill in the table to find how large a container he will need to hold the mixture if the amount of oil he uses is 1/8 of the oil bottle. Let's see how this table came out. Not too bad. I'm missing a number. It printed on the other page. Here we go. All right, so on Canvas, it tells you that 1/8 ounce oil, let's put our labels up here, oil, gas, and total. So if he uses 1/8 amount of oil and gets 4 ounces of gas, if we double that, he uses 1/4 ounce oil, so we need to double the amount of gas as well, which would be 8, which would make our total 8 1/4. So then to move this up from 1/4 to 1, we would times by 4. So do the same thing here. So we're going from here to here, we are multiplying by 4. We're going to do the same thing over here. 8 times 4 is 32. Then add these together. 1 plus 32 would make our total 33. So from here to get from 1 to 2, we times by 2. We're going to do the same thing here. 32 times 2 is 64. Add these together. 2 plus 64 gives us a total of 66. To get from 2 to 4 again, we multiply by 2. So we're going to multiply this one by 2 as well. So we get 128. And we add across, and we get 132. And we can multiply by 1.5. Or if you would like to add together the amounts on 4 and 2, that would get you to 6 as well. So let's do that. 128, oops, not times, plus 64 would equal, let's see, 2, 1 would be 6, 7, 8, 9, 192. And then we're going to add those together, and we get 198. Question 10 says, how large of a container will he need? So if we go back to our question, it says that he wants to use 1/8 of the bottle that he bought, which was 32 ounces. So we need to figure out what is 1/8 of 32. So we're going to do 32 over 1 times our 1/8. All right, so we take 32 over 8 and simplify, we get 4. So we know that he wanted to use 4 ounces of oil. So if we go back up to our table, this row right here is where we use 4 ounces of oil. So our container needs to be able to hold a total of 132 ounces. 132. Number 11, write an equation that relates the amount of gasoline Y needed for any given amount of oil. So we're going to go back up to our table and find where our oil was 1. We used 32 ounces of gas, so that would be our constant of proportionality. So our equation, put down here that my K is 32, would be Y equals 32 times X. All right, use the following information to answer questions 12 and 13. The train ride at the zoo covers a distance of 2.5 miles in 1/3 of an hour. Question 12, how many miles per hour does the train go? We're doing miles per hour. So in our problem, our miles are 2.5. Per means to divide, 1/3 of an hour. So in order to work this, I need to change this mixed number into an improper fraction. 2 times 2 is 4, plus 1 is 5. So we have 5 halves divided by 1/3. To divide our fractions, we keep change flip. So we're going to keep this change to multiplication and flip our bottom fraction. When we multiply, we get 5 times 3 is 15. Over 2 times 1 is 2. When we divide that out, we get that it is 7.5. So 1/2 or 7.5. All right, number 13, how far can the train travel in 3 hours? So we're going to take how far it goes in 1 hour, 7.5. and multiply that by 3. When we do that, we get 22.5. All right, next section. Use the following diagrams of the floor plans for a treehouse before and after reduction and enlargement by a copier to answer questions 14 through 17. Now this picture isn't very good, but you can use your picture on Canvas and zoom in so you see a little bit better. We may look at this picture, which is on the paper copies of the study guide as well. All right, question 14. What is the scale factor from the original design to the enlarged design? If you get a fraction, report your answer as a decimal. So we're going from the original to the enlarged. So original to the enlarged. So this is our start and this is our finish. So this would be our X and this would be our Y. So I'm going to use side links that are in corresponding places. So I'm going to use this top edge. So I'm doing my Y divided by my X. So 4 divided by 2 is 2. So my scale factor would be 2. 15, what is the scale factor from the original design to the reduced design? If you get a fraction, report your answer as a decimal. So we're going from original to reduced. So original to reduced. This is our start, this is our finish. So X and Y. So 1 over 2, which we can simply put in as 1/2, but we want a decimal, so 0.5. Question 16, which statement tells how the perimeter of the original compares to the perimeter of the reduced? So if we're looking at the perimeter of the original to the reduced. So we know if our scale factor is 1/2 this way, our scale factor the other direction would be the reverse. So it'd be 2 divided by 1. So this one is actually twice as big as this one. So let's see, the perimeter of the original design is twice the perimeter of the reduced. Question 17, which statement tells how the area of the reduced design compares to the area of the enlarged? So this time we're going to be talking about that scale factor squared. So we're looking at reduced to the enlarged. So how does this area compare to this area? So if we're starting here and ending here, we would be, or other way, we're starting here and ending here. So our scale factor would be 1/4, but we need to do that twice since we're talking about area. So 1/4 times 1/4 is 1/16. So the area of the reduced is 1/16 of the enlarged. All right, question 18 is find the perimeter of the image if the original perimeter was 8 centimeters and the scale factor is 2. For this one, it doesn't matter what our image is. We have all the information we need. They tell us that our perimeter is 8 and we're using a scale factor of 2. If we're talking about perimeter, we're just talking about the side links, so we need to take our original perimeter and multiply it by the scale factor 1 time. So 8 times 2 is 16. Question 19, find the area of the image if the original was 7 square centimeters and the scale factor is 4. So since we're talking about area, we have to do our scale factor 2 times. So we're going to do 7 times 4 times 4. When we do that, we get 112.